Now if you've seen part 2, you'll notice that the data is exactly the same as the previous problem. So this is the problem about logging in the rainforest, how logging, clearing and burning affects the rainforest, and it causes the destruction of the rainforest. And how do we measure it? By measuring the number of tree species in the unlogged and the number of tree species in the logged. So we have about 12 unlogged plots. So the sample size of the unlogged is 12. We measure the number of tree species in each of these 12 plots of unlogged, and we measure the number of tree species in the logged plots. So these are the logged plots, that's 9. We use the subscript U for unlogged and L for logged. So we say NU is equal to 12 and L equals 9. So it's more convenient to use the letters that remind us of the samples. So we know which sample we are referring to each time. The first question says, loggers are unaware that the effects of logging would be assessed. It is important to know this because this tells us that the study is blind. It tells us that there was no bias. If the loggers were aware that the effects were being observed, then that would change their behavior and they wouldn't do as much logging, possibly. Now another thing that is mentioned here is that plots were randomly assigned. This kind of tells us that it is a simple random sample. So the conditions for using the two sample procedure, because we have two independent samples, the conditions are satisfied. Now the data for the previous part and this part are exactly the same. However, the question is different. The question here says, does logging significantly reduce the mean number of species in a plot after 8 years? So we follow the 4-step process. Here we are not constructing a confidence interval because we are not estimating a mean. We are finding we're doing a hypothesis test because we're answering the question, does logging significantly reduce the mean number of species? So this is a hypothesis test. So far, we know two things. One, that it is a two-sample procedure, and two, that we need to do a hypothesis test. So let's just first make a statement. We're going to follow the 4-step process. We're not going to jump into the calculations as yet. We're going to make a clear statement about what we plan on doing. So we will find evidence to show that the logging significantly reduces the mean number of species in a plot. So where do we get this from? From the question that is being asked. The next step to the 4-step process is formulate. Here we are thinking through the given details and making a plan. How do we go about solving this problem? We have two independent samples, so it's a two-sample process, and we're going to use the two-sample procedures to do a hypothesis test using the formula. We always end with the formula to find the T statistic. We're expecting the number of tree species in logged areas to be less than the number of species in the unlogged areas. And that's the reason why we're taking unlogged minus logged. So this gives us a positive number. It's easier to explain a positive number. So we'll use the subscript U for unlogged and L for logged. So we write down the formula for the T statistic that we're going to use to find the p-value using table C. The formula that we use to find the T statistic is given here. This formula will now tell us exactly what we need in order to complete this problem. So what we need is the means of the standard deviations of the two samples, and the sample sizes of the two samples in order to figure out the T statistic. Now here we solved the problem. So the first step to solving the problem, which is the hypothesis test, is to set up your null and alternative hypothesis. This is the first thing that we need to do in a hypothesis test. We need to know what we're trying to prove. We're trying to prove that the mean number of species in logged is less than the mean number of species in the unlogged areas. So that would give us the alternative hypothesis. Just make a correction here. It's the alternative hypothesis, which says that mu u, which is the mean of the unlogged, minus mu l, which is the mean of the logged, is greater than 0. And how do we know that it's greater than 0? Because the mean of logged is less than, we're expecting the mean of logged to be less than the mean of the unlogged. Since we have the symbol greater than 0, so we're going to use a one-sided test. So this is our alternative hypothesis. What is our null hypothesis? The null hypothesis, what we're trying to disprove is that there is no difference. It's usually a no difference statement. There's no difference in the two types of plot, which means the mean that we get from the unlogged has to equal the mean that we get from the logged. Or when we take the difference of the two, mu L minus or mu U minus mu L has to equal 0. The next thing to do in a significance test or a hypothesis test is to set up our standard, which is alpha equals 0.5, that is significance level of 5%. 5% is the same as 0.05. So at a significance level of 0.05, we need to prove that logging actually makes a difference. So now we use our calculator to figure out the sample mean, the sample standard deviation of each individual or independent sample. And then we plug in all the numbers into our formula. This table gives us a summary of results, the sample sizes, the means and the standard deviations of the sample, all given in the form of a table. The formula for T statistic is given. I've changed the subscripts to U and L just to remind us of what these two samples are. I put parentheses here just so that you can see that if it's entered exactly this way into your calculator, you get 2.11. So all we've done is plugged in the numbers that we have, some that we already had and the others that we got from our calculators, to find the T statistic. So in the sampling distribution, if we assume that the null hypothesis is true, our T statistic is falling at 2.11. Now, the degrees of freedom for this problem we've determined has to be the smaller of the two numbers, that is 12 minus 1, which is 11 degrees of freedom for the first sample, and 9 minus 1, which is equal to 8 degrees of freedom for the second sample. We take the smaller of the two and use that in table C to find the p-value. Now we're going to use table C exactly as we did before in chapter 17. Our T statistic is T equals 2.11. We go to table C, but in order to use table C, we need to know the degrees of freedom. We pick the smaller of the two degrees of freedom, so the degrees of freedom that we take to table C is equal to 8. Now, the next thing is in table C, we look at the 8th row because we have 8 degrees of freedom. You're not going to find 2.11 in the table. However, you can find two separate values between which 2.11 lies. So according to the table, 2.11 lies between 2.306 and 2.449. Once we know the two t values, we go to the bottom of the table to find the corresponding p-values. The p-value for 2.306 and 2.449 are 0.2 and 0.25. So our p-value lies between 0.02 and 0.05 because our t value lies between 2.306 and 2.449. Just notice that the smaller number should be on the left, the larger number on the right, and the p-value that we need, the larger value on the right, sorry, that's the number, and the p-value that we need lies between the two. We compare the p-value to our significance level of 0.05. And notice that if the p-value ranges from 0.02 to 0.025, then clearly that would be less than 0.05. So right away, we know that we are able to reject the null hypothesis because our p-value is less than the significance level or the standard that we set at the beginning of the problem. Finally, we make a conclusion. We have evidence to conclude that, and as soon as you use the word evidence, you need to provide or present your evidence. Your p-value lies between 0.02 and 0.025. So we have evidence to conclude that the mean number of species in the logged plots is significantly less than the mean number of species in the unlogged plots, proving that logging significantly reduces the mean number of species. We make this conclusion only because we have evidence, which is the p-value lying between 0.02 and 0.025.